In this lesson, we will study applications involving quadratic equations. All right, check this out. The beach volleyball court at Lake Gen State Park measures 24 meters by 16 meters. The playing area is surrounded by a free zone of uniform width. The area of the playing area is 1/3 of the area of the entire court. How wide is the free zone? All right, so to me, this sounds confusing until we see a picture. So let's draw a picture. So here we have the entire court, the entire volleyball court. Now what the problem calls the playing area is right here. This is where they actually play the volleyball game. And all of this out here is called the free zone of the volleyball court. Now, the entire volleyball court is measured 24 meters by 16 meters, like we read. And the playing area is surrounded by this free zone, right? This is the free zone of uniform width. Uniform width. That means this is X meters. This is also X meters. This is also X meters. Although my picture might be a little off, all of these measures are the same. That's what's meant by uniform width. Okay? All right, what we are being asked to find is how wide is the free zone? How wide is the free zone? Basically, find X. Now, what we do know is the area of the entire court. Remember that the area of a rectangle is length times width. So the area of the entire rectangle here, the area of the entire volleyball court is 24 meters times 16. Now, what about the area of just the playing area? So just the area of this rectangle in here. Well, we would need this length here times this length here of the playing area. Now, we're not given that, but I think we can figure it out. If all of this width here is 16 meters, then this would be 16 minus this distance and minus this distance. So basically, this length here would be 16 minus x minus x. In other words, 16 minus 2x. This distance here would be 24, right? All of this. 24 minus x minus x. That is to say, 24 minus 2x. Now, the piece that's really going to help us here is the playing area is 1/3 of the area of the entire court. So this here is the area of the playing area, all right? And this is 1/3 of this area. So we can set up an equation here that I will write now. So this is what we have. This is the area of the playing area, and it is 1/3 the area of the entire court. So what we can do here is solve this equation for x, and that will give us our known. That is going to give us the width of that free zone. All right, let's go for it. All right, the way I'm going to start simplifying the left-hand side is by what some people call foiling. I'm going to do 24 times 16 and then 24 times negative 2x. Now, 24 times 16 is 384. And then we have 24 times negative 2x, so that's negative 48x. Let me continue distributing. So it'll be negative 2x times 16 and then negative 2x times negative 2x. So then we have negative 32x, and then we have plus 4x squared. Okay? On the right-hand side, 1/3 of 24. 1/3 of 24 is 8. And 8 times 16 is 128. Because this is quadratic, and I know it's quadratic because it's being squared, the variable is being squared, that's the highest degree, highest power, I'm going to move everything over to one side. Basically, I'm going to subtract 128 from both sides, which means I'm going to subtract 128 from 384 and set this equal to 0. All right, so let me show you that. Let me subtract 128 here, subtract 128 here. Now, 128 minus 128, of course, that's going to give me a sum of 0. And, of course, we want to do 384 minus 128. But at the same time, I want you to notice that these two terms are like terms, so we're going to combine those, okay? All right, on the left-hand side, I'm going to start with the highest degree, so 4x squared. That's what I'm going to start writing down first. And then when I add these two together, I get negative 80, negative 80x. And then here, 384 minus 128, let's do that. So that's going to be positive 256. Don't forget that this is set equal to 0. What I would advise you to do next is make this easier to solve by dividing both sides by the GCF of, let's see, 4. 4 goes into every single term. So let's divide everything by 4, and it'll make these numbers maybe a little easier to handle. So here we end up having 1x squared minus 20x plus 64 is equal to 0. Now, what we'll try to do here is factor, and I can see that this is factoring like this. We need factors of 64 that are going to add to negative 20. Okay. What we'll do next is set each of these factors equal to 0 and solve. So we're getting either x minus 16 is 0 or x minus 4 is 0. When I add 16 to both sides, I get either x is 16 or x is 4 after adding 4 to both sides. So we have two proposed solutions. Now we have to figure out which of these proposed solution actually works. All right, so let's go back to the original problem and figure out which one of these really does work. All right, so here's the original picture here. Now, 16 meters is not going to work for the width of this free zone. And the reason is because if this is 24 by 16, this cannot be 16. If the width of the entire court, is 16 meters, then this width cannot be 16. So 16 does not make sense, but 4 does. All right, I'm going to further check or verify that 4 works. If 4 meters is the width of the free zone, that would make the area of the playing area 24 minus 2 times 4, and then times 16 minus 2 times 4 as well. Basically being 24 minus 8, which is 16, times 16 minus 8, which is 8. So it'll be 16 times 8, which is 128 meters, okay? This would be the area of the playing area. Now, the area of the entire court is 24 times 16, which is 384 squared meters. Okay, actually, I made a mistake with my units here. Area is always squared unit, so this would, down here is 128 squared meters. This is the area of the entire court. This is the area of the entire playing area. And according to the wording of the problem, the area of the playing area is supposed to be 1/3 of the area of the entire court. So let's see if that actually checks out. If I take this area here, 128, and I multiply it by 3, do I indeed get 384? Let's do this math. Let's see, 3 times 8 is 24, right? Carry the 2, 8. Yes, that checks out. This value is 1/3 of this value, so we're good. So then the width is 4 meters. Actually, you see how I boxed this already? Let me take this back here if I can, or actually here, let me just scroll this down a little bit and write my final answer very formally here. 4 meters, okay? That is the width of that free zone. And this problem was interesting. It was fun. All right, let's check this one out. 3 towns, A, B, and C, are situated as shown in the figure below. The roads at A form a right angle. The distance from A to B is 2 miles less than the distance from A to C. The distance from B to C is 10 miles. We can fill that in, so this is 10 right here. Find the distance from A to B and the distance from A to C. Now, please notice that we do have 2 unknowns here, 2 things we want to find. This distance and this distance. Between these 2 unknowns, the one that I know least information about is the distance from A to C. That's what I know least information about because they gave me some information about the distance from A to B. They told us that the distance from A to B is 2 miles less than the distance from A to C. So they're giving you information about this length here. So I start with the unknown I know least information about, which is this length here. I'll label that X. If this length is X, then this one here is 2 miles less than that. So I'm going to say this must be X minus 2. Okay? The problem says that this length here is 2 miles less than that side. All right, because this is a right triangle, I hope you're thinking what I'm thinking. Let's use the Pythagorean Theorem, which says, most people know it as a squared plus b squared is equal to c squared. Now, that's fine. That's fine. But you must understand that a represents the length of a leg, and b represents the length of the other leg, and c represents the length of the hypotenuse. So one of my legs is just x, so I'll call that x squared, and the other leg is actually x minus 2, so I'll plug that in for b. And then c represents the length of the hypotenuse, which is 10, so I'll just write that as 10 squared. All right, what we're going to do here is we're going to solve this equation for x. But keep in mind, we're not done when we solve for x, because that's just one distance that we need to find. We also need to find this distance, which will just be 2 miles less than what you find for x. All right, so let's do it. What we're going to do first here is we're going to expand this perfect square binomial here. So it's x minus 2 times x minus 2. And then 10 squared is 100. What I'm going to do here is what some people call FOIL. Okay. And so what I have now is 1x squared out front plus x squared minus 2x minus another 2x plus 4 is equal to 100. Now, because this is quadratic, I'm going to set this equal to 0, which means I'm going to subtract 100 from both sides, which means subtracting 100 from 4. And of course, this sums to 0. But in addition to that, I am going to combine these like terms and also combine these like terms. All right? So then what we end up having is 2x squared minus 4x minus 96 is equal to 0. What I suggest you do at this point is divide everything by the GCF. So how about 2, right? Everything is divisible by 2. Every single number is even. So what we have now is 1x squared minus 2x minus 48 is equal to 0. Now, whenever we have a quadratic like this and we set it equal to 0 and then we try to factor it. So I'm going to try to factor this. It must factor as x times x if it's going to factor, and the signs must be different, right? And I know that because 48 is negative. I want factors of negative 48 that are summing to negative 2. And I think that would be negative 8 and positive 6. 8 times negative 6 is negative 48, and negative 8 plus 6 is negative 2. So this definitely works. All right, so I'm going to set each of these factors equal to 0. And I'm either getting that the distance of that one leg is 8 units or it's negative 6 units. Now, let's go ahead and toss out this negative answer because you and I are finding distance, and distance does not make sense to be negative. So that leg, I'm going to scroll back up if you don't mind to our picture, and we just found that the leg must be 8. Where's our picture? There it is. All right, there's our picture. And we just found that x is 8. Now, if x is 8, that means this side is 8 minus 2. If I could just move that b, it's kind of in the way there. Which is 6. 8 minus 2 is 6. I'm going to put an equal sign here. Is equal to 6. Okay? Now, let's not forget units, all right? It said find the distance from A to B. So let me write out my answer very formally, okay? So from A to B, all right? From A to B, we have 6 miles. If you read the question carefully, we're talking about miles. And then from A to C, we have 8 miles. All right, everybody, this is your final answer. Awesome. How fun was that? All right, look at this. Melanie plans to build a fire pit in her backyard at a safe distance from both her gardening shed and her daughter's playset. The 3 structures, both the fire pit, the gardening shed, and the playset, will form a right triangle, with the distance of the fire pit from the gardening shed 2 meters less than the distance from the fire pit to the playset. The distance from the playset to the gardening shed is 20 meters and forms along a side of the triangle. How far is the fire pit from the gardening shed and from the playset? So I think for sure here we need a picture. All right, so I've drawn the 3 structures and I've drawn a right triangle. Now, it does say the distance of the fire pit from the gardening shed is 2 meters less than the distance from the fire pit to the playset. So I do know that the fire pit is closest to the shed, okay? Now, it said, one more time, the distance from the fire pit to the gardening shed, so this distance here, is 2 meters less than this distance here to the playset. Because this distance here is what I know least information about, I'm going to start there. I'm going to make that my unknown. I'm going to call it x. That means this distance here would be x minus 2. Okay, this is 2 meters less than the distance from the fire pit to the playset. Now, what they do tell us is that the distance from the playset to the shed is 20 meters. So I can go ahead and plug in 20 meters here. Do you see how much a picture, a correct diagram, will help us here, right? All right, so we are going to use the Pythagorean Theorem again here. Let me move this over so I have some room to work this out. So what I'm going to do is use the Pythagorean Theorem to say x squared plus x minus 2 quantity squared must be equal to 20 squared. Remember, that's what the Pythagorean Theorem says. It says one leg squared plus the other leg squared gives you the square of the hypotenuse. And so what I'm going to do is write this as x squared plus, now we do know that x minus 2 squared means x minus 2 times x minus 2. 20 squared is 400. All right, so I'm going to distribute now. Okay, and so I have x squared, and then plus, when I start distributing, I get another x squared, minus 2x, minus another 2x, plus 4, and this is equal to 400. Now, because this is quadratic, I'm going to set this equal to 0, and I also want to combine some like terms, okay? So first of all, combine these x squareds to be 2x squared. Combine these first degree terms, and let's subtract 400 from both sides. All right? Which basically means you're going to subtract 400 from 4. This right here sums to 0. And so our equation turns out to be 2x squared minus 4x minus minus 396 is equal to 0. To make this a little easier to solve, we can divide each term by 2 to make these numbers a little smaller and a little more manageable. So we end up with 1x squared minus 2x minus, now half of 396 is 198. And all this is equal to 0. Now, what we've been doing at this point is we've been factoring quadratics, right? However, I don't think we're going to get this to factor. But what we can use is the quadratic formula. So I want to show you how you can use the quadratic formula here to proceed. Okay? You can always use the quadratic formula to solve a quadratic equation. So please allow me to move this screen up here all the way like this. So I'm going to use the quadratic formula. Now, the quadratic formula, it is imperative that I understand what my leading coefficient is, which is 1. The coefficient of my first degree term is -2, and my constant term is -198. Okay? So then x is equal to, by the quadratic formula, the opposite of your b value, so that's +2, plus or minus the square root of b squared, so that would be -2 squared, minus 4 times a, which is 1, times c, which is -198. Now I have to erase what I just wrote in order to have space here. All right, so -198. Square root of all that over 2 times a. So then x is equal to 2 plus or minus the square root of 4 plus 198 times 4. Let's see, what is that going to be? All right, it is 792. All right, got it. And then everything over 2. So continuing to simplify, I get 2 plus or minus the square root of 796, and then all of this over 2. Now, what we need to do is simplify this expression. Okay, so let me move up here. All right, so what we've done in class is we have created a factor tree to simplify a radical like this. All right, so let's see if we can do that. So what I have, you can start with any two factors you want for 796. You know 2 is going to work, right? Because 796 is even. So you're going to get 2 times, let's see, 300, 398. Now 2 is prime, so we can go ahead and circle that. But 398 is not prime, so let's keep going. You can use 2 again because 398 is even. And half of 398, let's see, that'll be 196. 196. Excuse me, I'm sorry, 199, correct? 199. Yeah, 2 goes into 3 one time with 1 left over, 2 into 19, 19, and 9 times 18. Bring down the 1, 18. Yeah, okay. I'm just correcting my arithmetic. All right, cool deal. And so here we have it. And so 199 is also prime. So what we have now is x is equal to 2 plus or minus the square root of 2 times 199. This is how we've been simplifying radical expressions in our class. Now our index is 2, so I'm going to group those two 2's together. And so what ends up happening is getting 2 plus or minus 2 and then square root of 199 all over 2. Notice that everything is divisible by 2, so we are going to divide by 2, right? So this term is divisible by 2, this is divisible by 2, and this is divisible by 2. So I'm going to divide everything by 2, and I need a little more space here. So x is equal to 1 plus or minus the square root of 199. Now remember that x is the distance from the fire pit to the playset. Now you have two solutions here. You got 1 minus the square root of 199, or x is 1 plus the square root of 199. Now, this value here must be thrown in the trash, right? Because 1 minus the square root of 199 will end up being negative, and we can't have negative distance. Like, we can't say the fire pit is a negative amount of meters from the playset. That doesn't make any sense because this is a negative measure. So we're going to toss that out. Okay, this is let's say it doesn't make sense because it's a negative distance. Now, as far as x is equal to 1 plus the square root of 199, this can be punched into your calculator to be approximately 15.1 meters. Okay, approximately 15.1 meters. Now, let's go back to our picture now that we know what x is. Okay, so where's our picture of the yard, right? So here it is. If I can just get this on the screen. There we go. Now we just found that the distance from the fire pit to the play set, which is x here, is about, well, I should say about, approximately, right? 15.1 meters. That means this distance here from the fire pit to the shed is 15.1 minus 2. I mean, about, right, everybody? So it's about 15.1 minus 2. So it is about 13.1, approximately 13.1 meters between the fire pit and the shed. Okay, everybody? That was a little bit of work, but it was very rewarding. It was fun. All right, cool. I hope you enjoyed looking at a few applications of quadratic equations. I'll catch you later in another lesson. See ya.